Lesson 5.4 is about types of systems. So this is some vocabulary on the different types of solutions that you will get when you are solving systems of equations. So sometimes when you have a system of equations, they will intersect on a line. And when they intersect on the line, we know that they only have that one solution. So that would be what this graph would look like right here. Sometimes when your lines don't intersect, they are parallel. That means there's no solution to that system. And then if the lines are identical, meaning that they lie on top of each other, those are called coinciding lines, and they have an infinite number of solutions. And we've talked about that a little bit. That part is the less complex way of identifying and classifying systems of equations. But then you have these other terms: consistent, independent, inconsistent, and dependent. And so we're going to go through and we're going to learn how to classify those lines and what all of that means. So let's look at our first system of equations. This is where our lines intersect at one point, meaning that they have one solution. Okay. And let me get my highlighter real quick. So one solution. They are called intersecting lines. Okay. And they are considered consistent and independent. And you need to know those. Consistent meaning that they are, and independent meaning that they are their own individual line separate from the other one. Okay. And so their one solution would be 8, -4. Now, when you have two lines that are parallel, these are inconsistent because they do not intersect, but they are considered independent because they are their own separate line. Okay. So we have, when they're parallel lines, there's no solution. And they are inconsistent and independent. And then you have lines that coincide. That means they are the exact same equation. And so when you graph them, they'll lie on top of each other. And again, we call those coinciding lines. Now, I want you to look at the equation here. This equation, these equations don't look alike, right? But watch what happens when I actually solve this one for y. If I were to divide everything by 2, and I were to write this equation, y equals 1/2 x minus 2. See how they're the exact same equation? So when I graph them, they're going to lie on top of each other. They're going to share every single point together. That's why we say that they have infinite number of solutions. So let me go back and try to explain the difference between consistent and inconsistent and independent and dependent. Okay, I'm going to start with independent and dependent. Independent here means that they are their own separate lines. They're different equations. So they're going to have separate lines. Whereas dependent means that they rely on each other and they will be the exact same line. That's the way that I can differentiate between dependent and independent. So if down here, if you want to write this, independent own separate line, and equation. And dependent, same equation, or same line and equation. Okay, so that's dependent and dependent. Now we have consistent and inconsistent. So consistent means that they're going to intersect at a point or more than one point. Inconsistent means that they are not going to intersect at any point. So let's write that down here. Consistent lines or equations will intersect. Okay. Inconsistent lines or equations will not intersect. So when you're classifying the types of systems, you'll need to know these vocabulary terms, the types of lines they form, whether intersecting, parallel, or coinciding, and the number of solutions. One solution, no solution, or infinite solutions. Okay, so that's what this whole lesson is about, is being able to identify the types of systems we have. Okay, so let's go ahead and go to the next page. And you might need to go back and refer to all that vocabulary on the front. Okay, so we have three different types of graphs, and all we're going to do is we're going to identify whether they're inconsistent or consistent, dependent or independent, and how many solutions they have. So if I go back to page 1, independent means they're their own separate line, dependent is the same line. So would this be independent or dependent? Independent. So this is independent. Okay. The next one is it consistent or inconsistent? So consistent means that the lines will intersect at some point, and inconsistent is they will not intersect. So they're intersecting, which means that they are consistent. And how many solutions do they have? Yeah, this only has one solution because it intersects at one point. So one solution. Let's look at example 2. Independent or dependent? Well, they're their own separate line, so that makes them independent. And I know some of you like to abbreviate, and that is fine. IND or DEP for independent and dependent. And they do not intersect at any point, which makes them inconsistent. And because they do not intersect, they have no solution. Okay. So inconsistent could be INCON, and consistent can be CON if you want to abbreviate it. And solution can be SOL. So no SOL or SOL. Okay.
Can you put like just the difference?
What do you mean?
Like if it has one solution, then we put one.
Yeah.
Like it had no solution, then it'd be 0.
Sure, you could do that. All right. Example 3, independent or dependent. Well, because they are the same line, they are dependent. So you could put DEP if you wanted. Because they are the same line and they're coinciding, they lie on top of each other, so that would be coinciding. And they are, would they be inconsistent or consistent? Yeah, consistent because they share every point. And then they have infinite number of solutions. You could do the infinity sign for that one if you wanted to. All right. Let's go to the last page on this set of notes. Now, instead of looking at graphs, we're actually looking at equations. So we're going to determine the type of line, whether they're parallel, intersecting, or coinciding. We're going to determine if they're consistent independent, consistent dependent, or inconsistent independent, and we're going to determine how many solutions they have. So we're adding one more criteria on here, and that's what type of line they are. So in order to figure out the type of line, or any of this really, you have to have them in slope-intercept form. So let's look at example 4. Here, they are the exact same equation. So if they're the exact same equation, are they going to be parallel, intersecting, or coinciding? They're going to be coinciding. So we're going to write coinciding here. So since they lie on top of each other, we need to figure out, are they consistent and independent, consistent and dependent, or inconsistent and independent? I heard someone say it. Consistent and dependent. So it's that second one. So and then how many solutions will they have? Infinite. Okay, I'm going to do one more with you, and then I want you guys to work with your partner on the other one. We're going to do example 6. I'm going to move down to example 6. So example 6, we need to rearrange these in slope-intercept form. So we're going to have to do a little bit of work here. So let's go ahead and isolate the y by dividing all terms by 3. Okay. And we end up with y equals negative 3x plus 1. Do the same thing over here. All right. So now we need to identify, we know they're not coinciding, right? We know they're not going to lie on top of each other. Can anyone remember from last semester how we can identify whether or not lines are parallel? They have the same slope. Do these two equations have the same slope? No. How do you know? Yeah. This one, right? This slope right here is negative 3. This slope right here is negative 1. They have different slopes, which means that these lines will be intersecting lines. That also tells me that there will only be one solution. And now we get to the more challenging part, is determining whether they are consistent or inconsistent or dependent and independent. Now, I always remember that any line that is on its own, separate, that's not coinciding, is independent. They're independent from one another. So if I can remember that, then I go up here and I say, okay, then if they're independent, oh, well, I guess that doesn't matter the way that I'm thinking of. Are they inconsistent or consistent? They're consistent. So this would be consistent and independent. Okay. So for the other ones, what I want you to do, we have 3 more. You're going to work with your partners on these and you're going to classify them. Okay. And then we'll come back and we'll check our answers. So I'm going to pause the video while you do this. So go ahead and check your answers for 5, 7, and 8. Make sure you understand those. And on example 8, they look like they're the same equations, but their y-intercepts are different. So, so be very careful that you are converting them into slope-intercept form, because once I did that over here, I could tell that their slopes were the same, but the y-intercepts were different, meaning that they were parallel and not coinciding. Okay, so be careful with that. Make sure you're rearranging your equation. So are there any questions on this?
Why is example 7 parallel?
Oh, did I get that wrong?
I mean, it's the exact same, that's why.
Oh, you know what? I was just looking at the slope. You guys are correct. Okay.
That she was like, it's coinciding.
Okay, so it's coinciding. And that means that it's infinite solution. And that means that it is, so let me write that down. So coinciding. Infinite solutions. And it is consistent and deep. Oh, these are both wrong. Consistent and dependent. All right. So is that right? Everyone got that? Okay. All right. So that concludes lesson 5.4.